Hello everyone. This is a mini video recording for 1.04, which is measurement and length. Okay, so we are going to be talking about the number line, which sounds silly because we've been doing that since elementary school, but we're going to review it a little bit and apply it here to geometry. We're also going to talk about the segment congruence postulate and the segment addition postulate. Let's jump right into the number line. So it says, what is the length of AB? I want to pay close attention here to this notation. Remember when we said line segment AB, we did AB with a line segment above it, okay? When you see just AB by itself, that is notating measurement. So when we see just like right up here, we have AB or we have M of line segment AB. Both of those are fine for notating length of AB, okay? So let's look at the length here. So A to B goes 1, 2, 3, 4. So AB has a length of 4. Okay, the next one says BC. So we've got 1, 2, 3, 4, 5, 6. So BC has a length of 6. And the last one is the length of AC. So A to C, and we can say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I think you know where we're going with this. I think this is leading us into the segment addition postulate, but let's keep going here. So pay close attention to this one right here, because this is where a lot of people kind of make, our brain is just, we have been drilled in thinking that if we go to the left direction, then that is negative. But with distance or with length, we don't have a negative length, okay? So if they were to say, what is the length of AB? We already know that that is 4, right? If they say BA, it's the same. It's still 4. Even though we're going in the left-hand direction, it still has a length of 4 or a distance of 4, okay? Okay, so at times we might be trying to find the measurement between 2 points without a number line, right? So if it's just coordinates, not talking about a graph, okay, just a number line without an actual drawing, okay? You can subtract the coordinates of the endpoints, but then we're going to find the absolute value of the result. So let's see what I'm talking about here, okay? What is the distance between -4 and 10? I'm going to move that down just a little bit, okay? So what we can do is we can subtract -4 minus 10, or we can do 10 minus -4, and that's what they have right here, okay? So if we have -4 minus 10, we still have those absolute values, but -4 minus 10 is going to be a -14, okay? Over here, it's 10 minus a -4. Remember, those are going to become a positive. So that both of these answers here, they have those absolute values around them, okay? Remember that the purpose of the absolute value is to turn whatever is inside positive, or to guarantee that it's going to be positive. So this -14 with the absolute value around it is just going to become a regular 14. Same way if we have this absolute value with the 14, it's just going to be a 14. So the distance between -4 and 10 is 14. Let's do an example here. What's the difference between J and K? Hey, we've got a number line. Let's use it, right? Let's use it. But before I just go counting the distance between J and K, I need to pay close attention to how much the number line is going by. These are not going by 1, they're going by 2. Okay, so it'd be 2, 4, 6, 8, 10, 12. So the length of JK, or the distance JK, is 12. Okay, so the segment congruence postulate, this basically says that if you have line segments that are equal in measure, they're congruent to each other. And they don't have to be on the same line to be congruent. So if AB is 4 and CD is 4, then those two line segments are congruent. Remember, congruent means equal, okay? And this sign right here is the symbol for congruence. It's an equal sign with a tilde. So sometimes they'll use that congruent sign, and that's how we know the line segments or the objects, the shapes, whatever. That's how we know they're congruent. Sometimes they might give us the measurements, and then we know they're congruent. And other times, another way for them to notate is for them to give us tick marks. So notice that this here, we have 2 tick marks, tick mark, and then tick mark, tick mark. That tells me that those 2 line segments are congruent, okay, because they each have those 2 tick marks. Over here on this other side, we had just 1 tick mark. So that tells me that those 2 line segments are congruent, okay? So they could tell us the measurement, they could give us the sign for congruence, or they could use tick marks. Okay, jumping into the segment addition postulate. You're going to notice this a lot with geometry, that the concepts are really easy, but the names give us more stress than the actual information. So if you really want to sound smart in front of your friends or your family and just be like, oh yes, today in geometry, we learned about the segment addition postulate. You don't have to tell them that this guy is so easy. It just says if 3 points, A, B, and C, are collinear, and B is between A and C, then AB plus BC equals AC. Y'all, all this is saying is that if you've got 3 points and they're all on the same line, okay, 3 points on the same line, if you take this line segment, AB, plus the next one, BC, then they're going to be equal to AC. Whoa. So hard, right? So hard. So if AB is 5 and BC is 1, then that means that AC is 6, just 5 plus 1. That's all that is. Okay, so it takes a really easy concept and puts a fancy name with it. That's what we do here in geometry. Let's look at an example. Okay, so it says point C is on PT. Sketch a figure for each set of values and find the missing links. Okay, so point C is on PT. So we got to draw us a line here. We have a line, PT, and C is somewhere on it. I don't know where C is. Okay, we're just going to put it right there. It says here that CT is 78. Okay, CT is 78. Then it tells me that PC is 22. And they want us to find the length of PT. So they want us to find the length of PT, which is from P all the way over.
I didn't get that.
Oh, sorry, Siri. So let's see here. PC plus CT is going to equal PT. So we know that PC is 22. We know that CT is 78. So when we add those together, 22 plus 78 gets us 100. Okay, let's do another practice. What is the length of BC? Now, see, we have these tick marks, right? And the tick marks tell us, these 2 tick marks, okay, they tell us that those 2 pieces are congruent. So it tells us that DC is also 18. So to find the length of BC, we're going to say 18 plus 18, which equals 36. Let's look at this next example. What is the length of HN? Okay. So we know because of these tick marks, right, that these 2 pieces are going to be congruent to each other. So we can think of H as being the midpoint because it's right smack in the middle of AN. So we know that we want to find HN, which is right here, and that's just half. That's just half of our full line, right? So we know that HN is equal to 1/2 of AN. So 1/2 of 38. So what is 1/2 of 38? It's 19. So AH would be 19 and HN would be 19. Okay, one more example. Point B is between point A and C. AB is 9x plus 7, and BC is negative 3x plus 20, and AC is 39. What is the value of x? Okay, that's a lot of information there. I need me a picture, okay? So point B is between A and C. We don't know if it's in the middle. We don't know if it's near A. We don't know if it's near C. It's okay. We don't need that information. We just need to know, okay, it's somewhere between A and C, okay? Let's label what they give us, okay? So let's see here. I like to color code. So AB is 9x plus 7. And BC here is negative 3x plus 20. And then the last bit of information, they tell us that AC, which is the full line, okay, the full thing here, is 39. Okay, let's go ahead and write us out a formula, okay? So we know that line segment AB plus BC is going to equal AC. So AB, let's go ahead and plug in now. AB is 9x plus 7. And then BC is negative 3x plus 20. And those, when we put both of those together, they add up to 39. Okay, so our next step in finding or solving for x is to add our like terms. So we've got 9x plus a negative 3x, or you can say 9x minus 3, and that becomes 6x. And then we've got 7 plus 20, which would be 27. And that's still equal to 39, right? Now, we've got that x over here. We got our x's together. Let's take that 27 to the other side to join it with that 39. So we do the opposite to get it over there. So if it's a positive 27, we're going to subtract 27 to cancel it out. And what you do to one side, you must do to the other. So we end up with 6x is equal to 12. And our last step is to divide by 6 to cancel out. And again, what you do to one side, you must do to the other. So x is equal to 2. And is that all they want us to solve for? Yes, they want the value of x. So we are done right there. Be careful though on problems like this, because sometimes they might want you to actually solve for x and then plug in to your equations to find the actual length of AB or the actual length of BC, okay? So pay close attention whenever you are reading the problem to make sure that you're solving for the correct thing. Okay, guys, make sure that you're going through the lessons because there's still lots of vocabulary and information that I didn't go over in this mini video. And if you have any questions, reach out to your teacher. Thanks. Bye-bye.